Hello friends, welcome you all in my YouTube channel. I am Dr. Mohammad Sirajul Faizi, Assistant Professor, Department of Chemistry, LS College, Muzaffar. Today in this video, I am going to talk about chemical compositions. So let us start with the chemical composition. This is the chapter 8 of Zumtar book. So first we define the atomic masses. Balanced equation tells us the relative numbers of molecules, of reactants and products. Balanced equations. Carbon plus oxygen give carbon dioxide. One atom of carbon reacts with one molecule of oxygen to make one molecule of carbon dioxide. If I want to know how many O2 molecules I will need or how many carbon dioxide molecules I can make, I will need to know how many carbon atoms are in the sample of carbon. I am starting with atomic masses. Daltons used the percentage of elements in compounds. Percentage of elements in compounds. And the chemical formula, you know the chemical formula? Chemical formula to deduce the relative masses of atoms. Relative masses of atoms. Unit is the AMU, atomic mass unit. 1 AMU is equal to 1.66 into 10 to the power minus 24 grams. We define the masses of atoms in terms of atomic mass unit. 1 carbon atoms is equal to 12.01 AMU. 1 oxygen atom is equal to 16.00 AMU. 1 O2 molecules is equal to 2 into 16.00 AMU is equal to 32.00 AMU. Atomic masses allow us to convert weights into numbers of atoms. If our sample of carbon weight 3.00 into 10 to power 20 AMU, we will have 2.50 into 10 to power 19 atoms of carbon. So, you know the AMU, 1 carbon, this is the unitary unit functions. 1 carbon atom 12.01 AMU. Then this AMU unit will cancel out. You will get this much carbon atom, and you see the questions. So since our equation tells us that 1 carbon atom reacts with 1 O2 molecules, if I have 2.50 into 10 to the power 19 carbon atoms, I will need 2.50 into 19 molecules of O2. Now just correlate it, because this much need carbon. And now from the equations, we look at the equations, 1 carbon need 1 oxygen. So if you know the carbon, then just correlate with the oxygen. So example number 1, calculate the mass in AMU of 75 atoms of aluminum. How much? 75 atoms of aluminum. Determine the mass of 1 aluminum atom. 1 atom of aluminum is equal to 26.98 AMU. Use the relationship as a conversion factor. 75 aluminum atom into, now 1 aluminum atom is equal to this, so this atom will cancel out. You will get the answer in AMU. Chemical packages or moles. We use a package for atoms and molecules called a mole. A mole is the number of particles equal to the number of carbon atoms in 12 gram of carbon 12. 12 gram just 1 mole is equal to 6.022 into 10 to power 23 units. The number of particles in 1 mole is called Avogadro's number. 1 mole of carbon atom weighs 12.01 gram and has 6.02 into 10 to power 23 atoms. Just remember it. All these samples of the pure elements contain the same numbers, a mole of atom. Here also 6.022 into 10 to power 23. Lead bar, it is also silver bar, 6.022 into 10 to power 23. Here also how many atoms? 6.02 into 10 to power 23 atoms. Even though here 207.2 grams, silver 107.9 gram, here 63.55 grams. Pile of copper. So 1 mole sample of iron, nails, iodine crystals, lead, liquid mercury and powdered sulfur. So all contains same units. You see 1 mole sample of iron, this is the iron, nails, iodine crystals, this is iodine crystal, iron nails, and here liquid mercury and powdered sulfur. Now compute the number of moles and number of atoms in 10 gram of aluminum. Use the periodic table to determine the mass of 1 mole of aluminum. 1 mole of aluminum is equal to 26.98 grams. Use this as a conversion factor. What conversion factor? I already discussed in previous video. 4 grams to moles. So this is the 10.0 gram aluminum into just conversion factor, put it like that. So gram will cancel out. 1 mole aluminum divided by 26.98 grams. So this gram will cancel out. You will get answer in mole aluminum. Now second example. Compute the number of moles and number of atoms in 10 gram of aluminum. So use Avogadro's number to determine the number of atoms in 1 mole. So 1 mole aluminum is equal to 6.02 into 10 to the power 23 atoms. Use this as a conversion factor for moles to atoms. This is the moles to atom. So this is the mole, 0.371 mole aluminum. Now you have to convert into atom. So this is the conversion factor. 1 mole aluminum is equal to 6.02 into 23 atoms. So this mole will cancel out. You will get answer in atoms. So now example 3. Compute the number of moles and mass of 2.23 into 10 to the 23 atoms of aluminum. So use the Avogadro number to the number of atoms in 1 mole. So 1 mole of aluminum is equal to 6.02 into 23 atoms. This is also truth. Use this as a conversion factor for atoms to moles. So this is the atoms, and 1 mole is equal to this atom, then you will get the moles. So if you want to moles, then atom will cancel out, you will get the answer in mole. So compute the number of moles and mass of 2.23 into 20 atoms of aluminum. Use the periodic table to determine the mass of 1 mole of aluminum. You know that 1 mole aluminum is equal to 26.98 grams. Use this as a conversion factor for moles to grams. So this is the mole. 1 mole is equal to this. You convert into 9.99 gram aluminum. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.